Lesson 9's homework on average rate of change again. We're just going to continue our use of our main average rate of change formula, which is, and I'm going to write it off to the side, or up here up top again, y2 minus y1 over x2 minus x1. So the first one says the table below shows the average diameter of a pupil in a person's eye as he or she grows older. What is the average rate of change of a person's pupil diameter from age 20 to age 80? So we only need to focus on two lines here, the line for 20 and the line for 80. And now when we're using these, we are going to use them as if the age is going to be our x value and the range is going to be our y. So the 20 would be our x1, the 80 would be our x2, and then our 4.7 is our y1, and our 2.3 is our y2. So when we plug that into our formula, we're going to get 2.3 minus 4.7 over 80 minus 20. And if we look at that in a more simplified version, we're going to get negative 2.4 over 60. If we divide those two and simplify, we get negative 0.04 as our average rate of change. So we want to use units to interpret the meaning of this average rate of change. Well, if we go back, our y was our millimeters and our x's were our years. So if we look at that, and since our average rate of change is negative, we're going to say that the average pupil decreases by 0.04 millimeters per year. All right. And again, the reason it decreases is because our average rate of change was negative. If it was positive, it would increase by 0.04 millimeters per year. But since it's negative, we're going to decrease. In our second one, they've asked a couple like these on the regions, and it's really important that we make sure that we actually do the average rate of change formula for each interval. If you don't, you are going to very likely get this question wrong. So they give us all these intervals that they want us to do. And what we have to do is we have to do them answer choice by answer choice. So the interval is from 1 to 2. So as we do that, what we're going to do is we're going to try to establish our points. So the points for number 1 are 1, 0, and 2, it looks like it is 9. So we have x1, y1, x2, y2. So we have 9 minus 0 over 2 minus 1 gives us 9 over 1, or an average rate of change of 9. So for our first one, our average rate of change is going to be 9. For the second one, and you just have to keep doing this process the entire way down. Answer choice 2 says 1, which we already know is 1, 0, and 3.5. 3.5 is at our, what looks to be our maximum value of 17. So 17 minus 0 over 3.5 minus 1. That gives us 17 over 2.5. And when we put that into our calculator, we get an average rate of change of 6.8. So since they want to know which one is changing the fastest, we know it's not going to be choice 2. I'll come down here now for choice 3, 1, which again we know is 1, 0, and then 5. 5 is going to be 5, 0. Now this one should be easy. Although it has a big change, its average rate of change is actually going to be 0, because the same amount that it goes up is the same amount that it goes down. So therefore, its average rate of change is technically 0. So we know that one's out. And last but not least, we have 0 and 3.5. So we know we have, so new point here, we have 0, -5, and we already know our 3.5 point is 17. So when we plug in 17 minus a -5 over 3.5, 0. So negative minus minus becomes plus plus. We end up with 22 over 3.5, which gives us an average rate of change of 6.2. So we know that one is still not bigger than our average rate of change for choice 1. So our answer here is going to be choice 1, the interval from 1 to 2. Now if you look at the graph, it might seem as if some of the other intervals are a lot bigger when you just look at it visually, especially choice 4. So that's why you have to actually make sure you sit down and do the equation for all of them to find the one that actually works.